Welcome back to the channel, it's Mark from PowerSonic and Apprentice 1-to-1. We are on site today doing a garage sub-consumer unit leading onto a hypervolt. Thought it was quite an interesting one. Let's get straight on with it and see what we're up to. I had to stop that recording because Matthew's drilling far too loud, but to explain the circuit down here, you'll have seen this install on 3 or 4 videos before maybe, where I swapped the consumer unit to an M2 board. We're going to bring a 3-core 10mm cable down here. That's going to be on a 50 amp MCB. I was going to go for the RCVO in that board, if you remember, way back when, just for the EV charge point, but install's changed now with the issues with that behind me there. And also thank you to M2 who got in touch with me through Twitter to say that actually their RCVOs are single pole solid neutral, even though on the CEF website it does say they're double pole. So massive thanks for that, for letting me know. So we're going to go for an MCB at the load end, 50 amp breaker down here to the garage, where we're going to split those circuits via a double pole RCD and then go off to just feed these couple of sockets and the hypervolt itself. So the hypervolt will be on a B32, the sockets will be on the B16, and then we've got the load limiting going back to the tails as well. But I'll show you all of that coming through on the install. We'll get on with it. I've got a time lapse set up for the consumer unit there, you can see it's all set up ready to go. So we can do that, and yeah, we'll talk a little bit about the issues of selectivity between the MCBs in series. I've spoke about this before, very hard to get full selectivity, and obviously the setup we've got here is what it is. You know, we might be having a bit of partial selectivity there based on the upfront circuit protective device and then what we've got downstream here. Generally, if you skip a breaker value out every time you drop, perhaps consider using C types and B types as well. You can achieve a bit of partial selectivity, but ultimately, as I've shown before, if you get a severe dead short circuit, it's going to be very much bets off as to what goes first. But with it being a small domestic installation, simple little setup in someone's garage, it's not the end of the world in either regard, and it is what it is at the end of the day. There's only so far you can go with stuff. Plans change. This wasn't the original plan. We were just going to bring a cable down for an EV charge point. We could have still done that, I suppose, but take you around the side of the house and I'll show you why we've decided not to do that. So this is the existing cable down into the garage. You can see it's just some 2.5 twin and air. Comes into this fuse spare, which has been getting a little bit toasty. I'll show you why in a minute. You see there might be the evidence there of a bit of swapping about and changing. This white cable's going off to the house alarm, so we need to look at that as well. But if we step back a sec, you can see why those fuses might have been overheating. Got some heavy draw appliances on there, so we're going to get this sorted out. We'll go through in the video how we're going to do that. Let's get on with it. You see Matthew's busy and set up there with the Linean super clips. These are the 15 to 18mm ones. Nice tidy result. We're going to go along to that end corner, pop up the wall there, and it's straight into the consumer unit, if you remember from the video 3 or 4 ago, like I say. And we're going to pop that into a C50 MCB. Obviously we need to check RZS values to make sure that that's going to be okay. I already know. So we're going to do that. And then we've got our supply circuit into the garage where we can subdivide those circuits further for the EV charge point and also the sockets in the garage. We do also need to remember that we've got the load limiting cable as well, and because we're not going direct back to the consumer unit for that, you're around the meter cabinets there, so we're going to drop that into the meter cabinet itself, and I'll show you how we're going to do that as well later on in this video. That's to just make sure we're not putting the main service fuse at risk, but we need to remember also with the circuit arrangement we've got and the selectivity I spoke about, we don't want to be tripping that MCB unnecessarily as well due to overcurrent with equipment in use. So I'll show you how all that comes together as we move the video along. So I thought we'd do a bit of commentary over the top of some of this time lapse again. You can see me here just checking we do have isolation down to that spare. Obviously we are locked off and disconnected from the main distribution board consumer unit, and you can see me now starting to strip out the old cabling ready for the rejig. We've got some old sockets down here as well, and these weren't wired in the best way, so I decided we'd just strip the whole lot out again and put in from fresh, so we know that everything we're doing, you know, is up to standard, and we're not just re-energizing something which might be going to cause us a problem down the line. So you can see here I'm getting this circuit out from the fuse spare. We had, as I said, it was actually the ring that was flowing through the garage. So we've got the 2 conductors here, the in and the out, and this was actually the upstairs socket circuit. So we've popped these into a little junction box that we're leaving in the garage so that that ring is maintained, and pulling in a new circuit for our distribution board down at the garage itself. and you'll see me start to get on with that in a minute. Matthew's just at the other side of the garage installing the hypervolt while I'm doing all this, and he will come and get involved in this little corner as well. There was a bit of swapping and changing along the way, as is often the case, and Nathan getting involved too. We gave him the opportunity to dress up some of these sockets and the little garage consumer unit. Really important when you've got apprentices in your team, that they're not just fetching and carrying and doing all of the menial tasks, but that you give them an opportunity to work as electricians as well, develop their skills. So you can see I'm just popping that up out the way for now, trying to shape it round reasonably nicely, so we've got a fighting chance of being able to leave that somewhere sensible and neat and tidy. And yeah, it is what it is really with that, isn't it? It's not a case of rewiring that entire circuit. We just want to make sure it's put back into service in a safe way. You see, if just getting on with stripping out the rest of these sockets now. There is another socket just round the other side of this garage wall, which isn't currently used for an awful lot. It's mainly there to just charge up the odd battery drill or something of that sort. The customer was just plugging in the EV charge point their EV charging cable to that socket. We'll talk about that in a minute. So you can see that's the socket stripped out. I'm quite happy with that cable that feeds around to the socket at the other side of the garage. There's enough length on there to tidy it up, but just showing that we were missing a fixing on that back box there. You might have spied that, so we need to drop another fixing in as well. But yeah, the customer had the cable that you get supplied with by the manufacturer to charge the vehicle up. As I say in the video, it is a hybrid. The range is 30 miles, so it wasn't an especially long charge time. But nevertheless, it brings into question all of those things to do with pen fault detection, because the lead doesn't have that built in. And equally, providing that permanent fixed load to an electrical socket outlet. We've all seen the footage already on social media of those socket fronts burning out. And I do believe in June this year they're actually going to be banned, those kinds of hookups to charge electric vehicles. I don't think they're going to be allowed any further. So you can see here I'm just getting my holes marked and drilled for that little consumer unit. Again, with the PPE, so we're making sure we're not damaging our eyes or our ears. And away we go. We can get that screwed back to the wall. Just make sure everything's lined up there. And this is a Luden board, and we'll speak a little bit about that as well. But there is a little fire grommet that goes in the bottom. You might be able to spot that there. So I've slotted the twin and earth cable up through that fire grommet. So we've got a bit of a seal and entry into the consumer unit. You'll note we've got the 25mm stuffing gland on the side there, and that's where we're going to bring in our NYY for the EV charge point. And we've also cut a little hole just below there for the steel wire armour cable coming in, and as I said, that's a 10mm 3-core, and they go into the 20mm steel wire armour glands. So you see we've jumped forward a little bit there, and we've got that on now. I would have liked to have brought the cables in a little bit further apart from each other. However, the way they enter into the building, and the way we wanted to keep the cable in over to one side of the garage, it made sense to just bring them in together. It wasn't that difficult, and we've used an earth nut on there as well. And again, with the earth nuts, you can with these, because we're in a metal enclosure, just rely on the piranha elements that stick out from that biting into the enclosure to give you your earth connection. But we always pop a fly lead on as well. Makes sense. If it's not 10 seconds work, isn't it, just to quickly make a fly lead up and pop it on there. And yeah, it makes for a nicer job. And also, never forget your little grub screw that goes in these to bite onto the thread. People often miss that off. So we've got that all nicely in now and glanded off. Matthew's currently working around the top of the building with the NYY cable. You might just see it dropping in there. And the cat cable as well. I think he's going to jump into shot in a second and use his very long arms to get this clipped up around the top. And you'll see Matthew providing some high quality video content here. There's less of this in the video just because this is how most electricians and other tradespeople will spend a lot of the time working, stood on the steps, popping hammers and drills between the legs while they're trying to get a cable or a pipe strung onto a wall. This is just what happens up and down the country every day, and Matthew's demonstrating it absolutely perfectly here. But yeah, you can see he's popping it over right into the corner. The idea was we'd get it right out of the way, drop it down the side. This boiler, it isn't tight to that corner. It appears that it is, but there's actually about a 600mm gap off the wall.
So we had plenty of room to get in and get our fixings on for the cable as well. Probably wouldn't have gone for that option if it was a bit closer. You know, it's just making access difficult for yourself to drill your cleats in and such. But yeah, he's getting that tucked away there. You see, with the NYY, I don't know if the apprentices watching this might not be familiar with it, but it's quite a rigid cable. It's easy to form into shape, so they're solid conductors, and you've just got to be careful that once you have kind of put it into the shape you want, that you're not repeating that in a different direction and stressing it. It's really difficult. Sorry, it's really easy to damage the conductors doing that. You see, using the Nipex dismantling tool there, and just ensuring we get a nice strip of the cable. Really useful tool for your steel wire armour and your MYY jackets. You see that's in there now. I'm just dressing this away. The beauty of the MYY is it comes with the right colours on all the conductors if you get the 3-core, and you can see we're in there now, just connecting in a way for the CPC, and we've also got the neutrals in there as well. And yeah, we've got the cat cable through too. That's for the CT clamp, and I'll explain later on in the video what that's about and why we've put it in here. There is a reason for it. You see there again, this is a solid conductor on the neutrals and the lines. So with the NYY, it's not fine stranded or 7-strand, it is a solid conductor. So you need to make sure you get a good termination on those and use your torque driver, which you will see me doing in a short while also. So there we are, I've just skipped forward a little bit there, and you can see the CT clamp, and I do mention this in the video, but that is rated for up to 600 volts. You see there I've got the weir torque adapter on the end of this weir driver, so that's set to the appropriate value for these Luden terminals, and it is actually written on the devices themselves, which is really very useful. So we can see me just nipping all those up, making sure we've got the right torque. And again, I have used some insulation tape around the terminations onto the data cable and for the CT clamp, really just to stop them flapping about so much, but it does also give them a little bit of something extra in terms of protection. They are rated for use inside this enclosure, but I always try and get them right out the way, away from all of the potential bitey stuff. So I've tucked them up behind the earth bar and wrapped them in a bit of tape as well. So you can see just busy away there, getting that as neatly dressed as possible. It's always a bit tricky when you're inside these small enclosures, especially when you've brought your final circuits into the side of the consumer unit. I would have much preferred to have dropped them into the top. Again, 2 reasons why we didn't. One is just to bring them down the side of the room, and the other, these have square knockouts in the top of those consumer units. They're not plain, and I guess that's my bad from an ordering point of view. Having said that, I would have still come down the side anyway. You can see they're just getting the buzz bar cover on and making sure we're all nicely in place. Socket fronts going on now as well, just tidying all this up, so a bit of handiwork from Nathan inside there. That's me checking Matthew's progress, see how far along he is, and then we can zip around and have a look at what he's been up to in a minute as well. I'll talk through him installing the Hypervolt, and then we can move on with the video and have a look at what we're doing with that steel wire armour cable feeding into the garage and how it's all going to come together at the end. See, they're just getting that closed up and we're all hunky-dory. I always go north to south on those screws if it matters to anybody. Some people go east to west. It often divides opinion, as most things do with electricians, to be honest. So you can see, just checking everything as it comes down. We've got everything nice and square, and we'll get on with fixing those cables back now. So that's me just popping in the, what am I doing there? Oh, the earth onto the front cover of this Luden board. So it comes with a little fly lead, and you must connect that into the earth bar and onto the front cover with the nuts and washers, and I'll speak about that in a little second.
So here's the little Luden garage board all finished. You can see we've got the fly lead onto the front cover, the back nut and lock nut on the front with the washers. Make sure you get those in the right order. We've got the earth bar up at the top there. You'll see with the fly lead actually goes into terminal 5 because the 2 earth terminals have been used by the fly lead onto the piranha nut and also the main earth coming in. Again, I've had to use earth tape on this. We forgot our earth sleeving today. Basics, but there you go. It's not the neatest when you're using tape, but it'll do. And likewise, we've over taped the Hypervolt clamp, fly lead, and the Ethernet cable coming in, data cable, whatever we're going to call it, just to give it a bit of extra something and stop it flapping around too much. So that's just not really doing anything other than tidying the cabling up a bit there. And then again, like I say, we've got the neutrals in to the main neutral bar, we've got the lines going into the MCBs, so we've got our B32 and our B20 down this end, 63 amp 30 milliamp type A RCCB, and then at the front end of this we have got our 50 amp MCB in that board I showed on 3 or 4 videos ago, I think it is. So we've got that supply circuit down here, and obviously this is a steel wire armour cable coming down to the garage, so we don't need to worry about RCD protection on that. And having found out that the M2 RCBOs are not double pole, this is why we've gone for this option. It seemed like the simplest. I know we've got RCD protection to these 2 circuits here combined, but it's not going to be the greatest inconvenience in the world if something was to go awry down here, so I can live with that. I think that's a reasonable solution. Just to mention, this Hypervolt cable is rated to 600 volts, so is the data cable we've used, so we're all good there for it being inside this enclosure. And yeah, we'll get on with the video. We'll just mention, because I always do with these, you've got the little instruction sheet here from Luden with the text specifications of this board. It tells you the torque values and also the sizes of cabling that it will accept. So it says here on the main switch will accept up to 50mm, and the MCB RCBOs 16mm, and your earth and neutral bars 60mm. So if you are using a 25mm cable going on a long run down to a sub board, you need to remember to use pin crimps on your final termination. Don't be doing bodgery and splitting the conductors between 2 terminals. You might as well have a pin crimp on there and do it properly. And then on this side you can see it just has some pictures on there, so it'll show you a little bit about how you address the cables in, the gland, the membrane, whatever we were calling it on there. I can get it to focus a bit better. And then some instructions for the consumer. So I'll leave this with the board, we always do. Let's get on with it. So that's it with the front on. You can see it does have an electric vehicle charger label in the kit, which is fantastic. We're just getting the other end of this hooked up, and then we'll run through some testing on the Hypervolt itself. Otherwise, that's this little bit done. See, using the full label kit, I'll just cover that QR code up. And yeah, again, just writing on the label, just so you can see if you're ever in a pinch, you can actually get this labelled up out of the box. We will be replacing all these with our own labels anyway. And again, the service make QR code is just so we can reference test results, pictures, everything back to this particular asset. Hypervolt has one of those on the product as well that we've popped on there, so it's all trackable. If the customer has an issue, they can report it to us very, very simply. And yeah, that's kind of where we're at. So I'll zoom back out and I'll show you what we've got in the garage as the finished result. So we'll have a little look at Matthew getting the Hypervolt on the wall. You can see he's got his SDS with the extractor on. We use the Hypervolt template, as you'll see him just there leveling up his holes. Really simple to fix. Couple of screws in the top and it slots down onto those, and then you put a couple of fixings in the bottom. All nice and secure. Cabling up as always, pretty straightforward. Again, MYY into the bottom, and we've also dropped our cat cable in as well. So you see we've got the Hypervolt at the front corner here. It was going to go the other side of this door outside, but the customers decided they want it in the garage. Their preference, so that's totally fine. See, we've brought down the 6mm NYY from the consumer unit, which is over in that back corner. And again, we've run a separate cat cable down to here just for the CT clamp, really to reduce cost, because it seemed like a bit of a waste to just use the EV Ultra cable when we're inside a garage. You know, it's not especially needed to be neat and tidy to the point you've got just the one cable run, so it made sense to keep the cost down a little bit for the customer and do that. We've got this little drip loop on here just in case it ever does go through the other side of the wall, so there is the option there for them to do that. Yeah, that's sort of where we're at. I can't think of anything else I really need to mention on there. Steel wire armour down to the garage is 10mm, 6mm NYY to the Hypervolt. Yeah, it's got the CT clamp. Just to mention the CT clamp, we wanted to put it at this end. Customer and I had a discussion and we decided that that was probably the best option. The electrical demand in this house is really small. There is no electric cooking, electric showers. They've got the heat-only boiler back there behind me. That's filling a nice tank of hot water. There is a backup immersion heater, which I suppose could present a bit of a demand on the system. But we've got that 100 amp main service fuse. Generally just sockets and lighting. There's only 2 of them living here. That main service fuse is never going to be at any danger. We've had a clamp meter on this installed a couple of times we've been here, and the usage is tiny. So I'm not concerned about that service fuse popping due to the Hypervolt. But we have ramped it down to 20 amps max charge. And again, customer request, because they've got a hybrid at the minute. It's only got a 30-mile range on it. If they ever go full electric, we can revisit that. But yeah, they just wanted to kind of have the monitoring feature down on this board, so the upfront circuit breaker was never going to be in any danger. To be fair, it wasn't, because we've got that 50 amp MCB. But customers always right if they have those concerns and they're worried about stuff and they want a particular setup on their installation. As long as we're not doing anything that's against regulations or causing a problem for the DNO, I don't see the harm, and that's the option we've gone for. If ever we do need to put the CT out to the meter box main supply, you've seen it, it's literally just around the corner, and that, well, about 7 meters away. So it wouldn't be the biggest job in the world to just tie a cat cable on and take it down there. So yeah, that's what we've gone for at the minute. Just thought I'd explain that. The original intention was to go back to the meter box, but change of plan. We'll get some testing done on this bad boy now. So we've got the EV Test 100 down there. You will see that it is blinking away there, probably on your screen, but it is a solid red in front of my eyes to say that we are in a charge state. Hypervolt's on and powered up now. I'm going to run through a full test sequence. I'm out with Matty today, so I've only got the TIS MFT Pro, which is my old one, which is now his. So we're going to do that. Obviously go through the full range of tests. I'm not going to show this on this video again because I've done loads of EV videos over the last few weeks. We even had Steve from TIS demonstrate a full test sequence, so if you want to see that, go and check out the earlier video. We're just going to put this all together now. We'll run through some of the different lighting features with the customer, make sure they're happy with the app, and then I'll jump back on and we'll talk through the install a little bit at the end. Okay, so that was another EV video closed up there, and you will have seen it wasn't a straightforward one. And that leads me on to a little bit of a rant for the end of this video. I've saved it for the end because no one likes a ranter, so I'm going to drop it out on the front of this one. But it's to do with manufacturers who are kind of suggesting these ridiculous prices to consumers, creating this false expectation of what an EV installation should cost. We've all seen it. You can go off to pretty much any of the main manufacturers' websites and they will tell you EV charge points installed from £600 after your EV grant. Some of them will even take the money from the consumers based on those prices, and then when they actually go out to survey, do such things as push the installation into the future 6 months to put the customer off, or just drop the customer entirely because they've realised the actual job is far more difficult than £600 plus an EV grant payment. So it comes back a little bit to who is really the people who can advise consumers best on what it costs to have an electric vehicle charge point installed. And in my opinion, it's quite clearly electricians. And as we know from the very varied housing stock we have in the UK, to put some sort of blanket cost towards that is really rather silly. It makes absolutely no sense whatsoever. And it is the equivalent, in my opinion, of us as electricians dictating to the manufacturers what their products should cost when they are sold to the consumers. We have no idea what their manufacturing costs are, no idea what their shipping and delivery costs are, component costs, whatever else. We could never even go there. So I do not understand why the manufacturers are trying to push that onto us as to what we should be charging, what consumers should expect. It just gets that whole first interaction off on bad footing. We will often hear that from some consumers we've been in touch with. Oh, we've been on the website and we've seen it's supposed to only cost us £600-700. How come your quote's £1,200, £1,500, whatever it may be? And it's creating that awkward conversation right from the very beginning, creating those doubts of trust and ultimately, an unfair sales system. And I would like to see that stop. I think it's far better that us as electricians make those purchases from the EV manufacturers of the equipment that they are making, and kudos to them for that. Some of the product coming out now are exceptional, and we will deal with the installation costs of what consumers should expect to pay to have that equipment fitted correctly and safely into their homes. Because I do believe that some of this is driving the poor quality installations that we are seeing in the EV marketplace, where installers are rushing or trimming out certain bits of materials to compete with each other, or having put onto these jobs in a subcontract basis via some of these manufacturers. And it just seems so silly. I think we should stop doing it. Rant over. I hope you enjoyed the video. If you'd like to get involved in the comments about the installation itself, or if you have the same concerns around the way EV charge points and their installation are currently sold, get involved in the comments. Give me a thumbs up or a thumbs down so I know if you're enjoying the content or not.
and I will see you all on the next one. Thank you very much for sticking through to the end. Catch you later.